All right, we've all been there, right? You're surfing the web, you're in the zone, and then bam, you hit a wall, an error message. But what is it actually trying to tell you? Today, we're going to pull back the curtain on one of the most common ones you'll see, the 502 error. Let's get right into it. You know the feeling. You click a link, you're ready to see that page, and instead you get this digital brick wall with that sad little broken robot just kind of staring back at you. And yeah, it's super frustrating for sure, but it's not just a dead end. It's actually a clue. See, this screen isn't just saying, oops, something's broken. It's sending a very specific message, kind of like a distress signal from deep inside the internet's machinery. So our mission today is pretty simple. We're going to decode that signal and figure out what is really going on. To crack this case, we're going to start by looking at the clues that are hiding in plain sight right there on the screen. And the biggest one of all is that number, just staring right back at us. That number, 502, it's not random at all. It's part of this, well, it's kind of like a universal language for the internet, a whole system of status codes. So if you see a code in the 200s, everything's great. A 400-level error, that usually means the problem's on your end, like maybe you typed in the web address wrong. But a 500-level error? Aha, that tells us something important. The problem isn't with you, it's with the website's computer. And to get that, we need to quickly talk about what a server is. You can just think of it as a really powerful, specialized computer. Its whole job is to store all the data for a website, all the pictures, the text, the code, and serve it to you when you ask for it. And that's the other key piece of the puzzle, a request. Every single time you click a link or type in a web address, your browser is sending out a request across the internet. It's basically saying, hey server, can you please send me the data for this page? So here's the most important thing to remember. This is the good news, right? When you see a 502 error, you can just take a deep breath and relax. Your computer is working just fine. Your internet connection, totally fine. Your browser sent the request perfectly. The problem is happening somewhere else entirely. Okay, so this is where it gets really interesting. A 502 error isn't just about one server failing. It's often called a bad gateway error. And that name tells us everything we need to know. It's actually a story about a communication breakdown between two different servers. Let's use an analogy to make this super clear. Imagine you're at a restaurant. You, the customer, order a meal. That's your request. Your waiter takes that order back to the kitchen. Now, in this story, your waiter is what we call a gateway server. And the kitchen? That's the main server that actually has all the website data. But what if the kitchen is totally swamped? Or maybe it's run out of an ingredient. It can't make your meal. So the waiter has no choice but to come back to your table and say, hey, sorry, there's a problem in the kitchen. That's a 502 error. The waiter, our gateway, is telling you it got a bad response from the kitchen. So let's just connect those dots one more time. You're the customer using your PC. The waiter, the first server your request talks to, is the gateway server. And the kitchen, the server that's further up the stream of information, well, we call that the upstream server. The gateway is bad because it got a bad or invalid response from that upstream server. Right, so that brings us to the next big question, doesn't it? What on earth could be going wrong in the kitchen? Why would that mean servers suddenly just fail to do its job? Well, it usually comes down to a few pretty common things. The biggest one by far is that the server is just overloaded. Imagine a tiny kitchen suddenly getting 1,000 orders at the exact same time. It just can't keep up. It's also possible the server is just down for maintenance, like the kitchen's closed for cleaning. Or, honestly, it could just be a tiny temporary network hiccup between the two servers. The waiter's message just got lost on the way to the kitchen. Okay, so if the problem is on their end, does that mean we're just stuck? We just have to sit here and wait? Well, actually, no. There is something you can do. And the best advice is right there on the error page itself. I mean, look at that. It's spelled out right there in plain English. Google's message is super direct. Please try again in 30 seconds. And that's not just some generic advice. It's actually based on the most likely reasons for the error. So why is that the best move? Well, think about it. If the problem is just a temporary overload, if the kitchen is just swamped, waiting a few moments gives the server time to catch up and sort itself out. When you hit refresh, you're basically sending the waiter back to the kitchen to try the order again. By waiting 30 seconds, you're giving the kitchen a fighting chance to get back on its feet. All right, let's zoom out for a second. The next time you run into this error, instead of just getting frustrated, you can see it for what it really is, a little peek behind the digital curtain. And our little robot friend? We used to think he was the problem, didn't we? But now we know better. He's not broken. He's the messenger. He's our waiter, just politely letting us know that the issue is a little further down the line. He's just the bearer of bad news.
It feels like a simple failure, but what it's really showing us is how unbelievably complex the internet actually is. For the web to work, literally billions of these invisible handoffs between servers have to happen perfectly every single second of every day. A 502 error is just one of those rare moments where we actually get to see one of the links in that chain break.
So the next time you see a 502, you'll know the story, the whole story of the waiter in the kitchen. But it kind of makes you wonder, doesn't it? That's just one hidden conversation in a massive, invisible network. How many other digital handoffs, how many other requests and responses had to happen perfectly just to bring this very explainer to your screen right now?